Okay, question 3 from tutorial 5. So here the 20 centimeter diameter and height is 60 centimeter vertical cylinder container is partially filled with 50 centimeter high liquid, and this liquid density is given 850 kg per meter cube. Now the speed is rotated at a constant speed. If your the cylinder is rotated at a constant speed, determine the rotational speed at which the liquid will start the spilling from the edge of the container. So for basically say if this on your container diameter given cylindrical shape, so diameter given say 20 centimeter and full length of the height of the container is 60 centimeter. Now from here is a field up to 50 centimeters, say around here, say is a 50 centimeter. Now here this up to this length is filled with the liquid, and this liquid density is given 850 kg per meter cube. Say like this is filled with liquid. So this one is the initial condition. Now if we start to rotate this container, so what will happen? So if I draw, say now with the rotation case, so if we start to rotate, say along this axis, so you at static position, your liquid level was here, so this is a free surface. So and when it will start to rotate, if we increase your rotational speed gradually, so your liquid will move like this, and if it's still increasing, so it will be free surface will be like this shape. So when your speed will reach at due to the speed rotation, so when it reach at the edge of the container, so it will start to spilling. So we need to find out the when it will start to spilling or at which speed. Now this one is free surface here. Same thing, this one also free surface, but in rotational case, this one also free surface for another angular velocity. Now, based on question, we can now there is a formula, so we can find out this free surface position from the bottom. Say for example, so free surface we define with the, say for if you consider from at the origin of your cylinder, the center, bottom center is a origin point. So here is your radius axis, and the vertical one is the z axis. Now if you want to find out, say for any particular case, your free surface position, so say for this point, if you want to find out the position of free surface from the bottom, so this one is the ZS. Now we can find out this ZS from the formula is H naught minus omega square over 4z, then r square minus 2r square. This is on the formula. If you want to find your free surface position. Say for example, if you want to find out for this point, the how much is position of free surface. So first part is your original liquid level with a rotation. Say for example, for this problem, your S naught is 50 centimeter. So your original liquid height. Then minus your omega is your angular velocity, the rotational speed. 4 times g is a gravitational acceleration. Then r square. So r square is a constant, is a radius of your cylinder. Now you can see the most of all part are constant, only variable part is this small r. Now this small r is your distance between your rotational axis. So rotational axis is a z axis here. So if you want to calculate a free surface for 0.1, so r will be this distance. So this will be your for 0.1 r. If anyone find out the how much zs is here, this height, say 0.2, so your r will be this distance. Then if you use this distance in your formula, we'll get the zs for 0.2. So now you can see the your r will be from rotational axis will be 0 to maximum will be the same as your radius. So r, if r is 0, so your free space length will be this length, the smallest one. And if r equal to r, so you'll get the free surface at the wall of the cylinder, the highest low distance for the free surface. So based on our question, so when your GS, it will be the equivalent to your container total height 60 centimeter. So your liquid will start to spilling. Now S naught is given 50 centimeter, and when your free surface location at the wall of the cylinder becomes 60 centimeters, it will start to spilling. So we can find out this one. So let's discuss the particular questions. So vertical cylinder, they give us the vertical cylinder contain partially filled with a liquid is rotated. The angular speed, we need to find out when it will spilling the liquid from the container. So we'll consider two assumptions. So first one is rotational speed is very slow, will increase slowly the rotational speed, and we will consider liquid in container always act as a rigid body, and bottom surface always will be remain the cover by the liquid. There will be no dye spot. This one means say for say if you dye spot means if you due to any particular angle, the angular velocity, so it can be like this. If free surfaces can be like this. So the bottom here we can see the our container bottom, and free surface will be here due to the angular velocity. But for this case, we'll consider it will never happen. There will be like similar to this type of free surface curve. So for example, similar to if I draw here for this problem, here we'll use the r axis. This one is our z axis, and so it will start to spilling from container when it will be like this type of. See. So the black one is your free surface also, but for the rotational case, and the red one free surface without the rotation. So now we select the center here, and at this point your r equal to 0, z also 0, and they give us the original liquid height is h naught. So he's this 50 basically the your h naught, the original height of the liquid before rotation, and maximum height of the container given 60 centimeter. That means when your free surface height of the free surface is at the edge, not here, so at the edge, when your free surface height will become as the container height, so we'll start to the spelling. So we'll use the h as a gs as a height of the container. So equation for the free surface of a liquid is given as you already know the equation is h naught minus omega square 4 g r square minus 2 r square. So here, so already know the gs will be the same as height of the container 60 centimeter. H naught will be the original height of the liquid in container 650 centimeter. Angular velocity is unknown. We'll find out when it will be spilling. Now radius, so diameter given 20, so radius will be 10 centimeter. And the small r, so we will calculate the free surface at the container wall. So your r will be same as this one. So your small r here, because it will be spilling from the wall, so it will be the same as radius of the cylinder. Now if you solve, we have the almost all of them, only the angular velocity is unknown. If we solve this equation for angular velocity, so we'll get the maximum rotational speed, because we consider gs as a maximum height as a 60, so it will give us the maximum speed. So at this speed it will exceed, it will become a free surface at the wall, it will be the same as the cylinder wall. Then if you increase more or after this speed, it will start to spilling. Now if we solve this question for angular velocity, so we can rearrange this one. So angular velocity formula, say for, if we write down, it will be zs minus s naught equal to minus omega square 2z and r square minus 2. Now small r will be same as radius, so r square. Now you can see inside there will be negative r square, so this negative will become positive. So we can write down omega equal to root over, oh sorry, this will be the 4g, it will be 4g zs minus s naught divided by r square. Now here we have the all values, so 4 times 9.81 is a 60 centimeters, so divided by 100, it will become meter. 50 centimeter divided by 100, radius given 10 centimeter square, then root square. So it will give you the maximum rotational speed is a 19.8 unit will be the radian per second. Now rotational speed also we can express by as a rpm, basically the revolution per minute. Now for revolution per minute, if you want to convert, so for one revolution is equal to 2 pi. So here we have the 2 pi radian, so one revolution equal to 2 pi radian, say radian. Now if you want to convert as a revolution per minute, so you need to divide it this one by 2 pi, so it will give you the revolution per second, but we want to convert to rpm, so revolution per minute, so it times the 60 second. Now it will become the rpm. If we solve this one, you will get the 189 rpm. That means if you rotate 189 RPM your cylinder, so your fluid will start to spilling. Okay. Now you can see they give us the density. Now my question is, if you put the another type of fluid, it will happen the same thing or will be different. So now say fluid 1, density given 850 kg per meter cube. Then you can see this fluid will start to, if you rotate at this speed, it will start to spilling. Now question is, if you change the density, so heavier than this one or lighter than this one, so your speed to, if you want to spilling these things, so your RPM will, you need to increase or decrease. So general question is, so you can think about it. So, and you can let me know if we find or if you can interested to discuss, we can discuss on the tutorial class. So it's best thing is is it depend on density or independent from density? Okay guys, thank you for watching.